Okay, let's go over a little bit about the machine. This is the top gantry. You can see the whole thing sitting here. If I can turn it, I guess it's hard to turn it that way. You can see the whole gantry there. Okay, that's the whole machine. This machine is all made with just 2x4s and some aluminum angle iron here and some steel angle iron on the bottom down here. Could have used aluminum down here, it just was cheaper. The wiring system here, you can see it, is actually, I use all the wires like off of a trailer. Just went to the store and bought a roll of trailer wires, you know, for doing the lights on the trailer. On the top here, the motor feeds through. I put these blocks here, these breakout blocks here, just so that I didn't have to rewire everything, and then it was easy to do. These are like a couple dollars at Lowe's or Home Depot, so they're pretty cheap. The motor, the router bit here, is literally just a $10 swap meet router. I took the bottom casing off of it to make it straight, and I just took a 2x6 here, cut a hole in it, put some screws down, and mounted this piece to this board. And the board, the Z-axis here, is a 2x6. You can see here, there's one of the limit switches, and it runs on two cabinet rails. They're, you know, for the drawers on the cabinet. I just mounted them sideways. It gives me a pretty good thing. Actually, these are the worst as far as holding alignment and stuff when it goes up and down. Those are the least precise of all of the things. These guys here on the rails, on the Z, and of course on the X, the only thing that's got screwed down is on the end down here. I just screwed down stops in there. I didn't want to put any screws along the track at all. You can see it's all there. Even though I have a little bit of room between the bearing and the bottom here, because as you put screws down and tighten it down, it causes warps in the track. So I wanted to have the material underneath support the track but not force the alignment, because this material here is just a 2x6. I took a drill here and drilled out a bunch of holes along there and then elongated that so it gives me some adjustment. And then this right here, I put on my table saw and just cut off two 45-degree angles and created the bevel. I could have used a planer or anything else to do it, but that's the most complicated cut on this entire thing, is this right here to make this angle. Other than that, everything is pretty much just really straightforward. I tried to design it to where I could use as simple tools as possible. All the 90% of everything I've done on here is actually use a normal chop saw or miter box saw, you know, just at straight angles to cut it, just to cut off the links and get the lengths, all square and common across there. Again, these are alignment screws here, so that once I built this square table, I needed a way to adjust the alignment to make it square, because this track and this track need to run really close to each other as far as being square. So what I did was I put these screws in here, and I was able to adjust, and it twists the frame of the whole thing to the point where I get a square box. And there's 4 of them. There's one on each corner, and there's 2 over there. Let's see, the limit sensors right here, the limit switches here, I think they cost me like $5 for all the limit switches. And for my emergency stop, which I added over here, see, little button, pop it in, it shuts down the tool. Let's see, standard motors, I think the motors were like $30 a piece. lead screws, I think, were like $10 a piece, and 2 of them. I had this little 1/4-inch lead screw I used for the Z-axis just laying around, so probably another $5. It's smaller than the other ones. Let's see, again, my fire alarm panels, which when I first did it, before I had those fire alarm panels, I had just a piece of plywood board, and I screwed all the stuff to it, so it ran before I did that. I also, these limit switches here, I had it up and running before I ever added the limit switches. I added the limit switches later as I improved the whole thing. One of the things you got to be careful of, and I did this when I first started it up. See these wires here? See the screws? These need to sit on top of the screws, right? And you can see kind of the bend in here. Even though I thought I had enough slack for this arm to move all the way across over to here, I didn't, and this caught in here and bound and almost tore the wire. It was caught right there. So you be careful when you're putting the wires on to make sure that you give enough slack and they have enough to run on. This big bundle of wire, the reason there's so much of it is because it's the same thing. It has slack. It comes over here, mounts over here, and then runs all the way back over there. And I just haven't assembled that. So basically, overall, it's pretty simple and straightforward. I designed it to cut wood, so there's not high precision with it, but it's simple and easy to make. I think the frame and all the 2x4s and everything else might have been $50 I spent on it. The motor's about $30 a piece. The most expensive parts were the electronics, the motor controllers and stuff like that. That's probably around $150. You can get them cheaper, but I've got, this is actually, you can see in here, I've only got 1, 2, 3 motors wired up, but this actually is a 5-axis motor controller because I got plans for it later as I upgrade it. So I got something a little bit more, but you can get them cheaper. I wanted the display, I wanted the remote control, and I wanted to have these motor drivers separate. But you can get these motor drivers, you can get them to where they'll do the job for 10 or 15 bucks a piece, and the driver board for, you know, probably somewhere around that same price. So and then I bought a power supply, switching power supply, because I wanted stable power on it. I did find out though on this one here, this one runs off of a little USB power source right here. It's actually a USB here. I used a smaller USB transformer and plugged it in originally, and it didn't have enough power when the motors were in full, they were driving. It would actually kind of skip out. So by just replacing and getting a bigger transformer, you know, like for a bigger iPhone or something, it solved my problem. It made the driver board be stable, and it runs really good now. So this right here, this is something I added. The servo control, it actually, I have it plugged in. It actually plugs into that cable, and it switches my my router on and off by itself. So I don't have to flip it on or do whatever. It's all automatic, and the software when you're running the G code actually tells it to turn on, and it all functions pretty good.